when Wegener came along with this idea of continental drift, it really, it took people by surprise, and people didn't want to believe it.
He was the first one who really kind of laid it all out for us. Of course, everybody who believed something else would fight back.
There are periods in the history of science where there are problems that can't be solved, and scientists just say, we don't have an answer for this right now. And that's effectively what Americans did in the 1930s.
By modern standards, the work of early cartographers can charitably be described as creative, but hardly realistic. The Waldseemüller map, published in 1507, was the first map to identify America by name. But anyone hoping for an accurate representation of the New World would have to wait. Eventually, of course, map makers were able to reproduce the nooks and crannies of the world's coastlines with startling precision. And certain unmistakable similarities became strikingly clear.
Back in the late 1800s, it was discovered, and it's almost like any child who looks at a globe can pretty easily decide that Africa and South America look like they fit together, parts of a puzzle. Well, that's how the whole thing started.
This jigsaw puzzle fit was actually recognized 200 years earlier. Sir Francis Bacon had actually recognized that there was this apparent jigsaw puzzle fit as soon as the first accurate maps were made of the coastlines.
But also the geology fit very well. A lot of mountain ranges were broken at the edge of the continents and continued on others.
And then, of course, the geologists who were working in North America and Europe said, well, we've got the same kinds of rocks, similar belts of the same age rocks with the same fossils in them in these two places, and that looks like it matches up too. There was also a lot of good geological evidence from South America and Africa with a similar sort of thing. And so the geologists were a very important part of this concept after, the map makers, because they had additional points that they could correlate and say these pieces must have, started out together.
As early as the mid-19th century, people had recognized that the pattern of fossils around the world didn't make sense. And the way in which it didn't make sense was that fossil assemblages in places like South Africa and South America were almost exactly identical in certain parts of the geological record, even though these were environments that were thousands and thousands of miles apart.
By the early 20th century, the intriguing congruence between distant coastlines, rocks, and fossils was well recognized. But no one had yet proposed an explanation. In 1912, all that would change.
The idea of continental drift was proposed by Alfred Wegener. This was totally against anything that had been proposed prior to this. His idea was that at one time, all the continents had been joined into a supercontinent, which he called Pangaea. And there was ample evidence that he saw that supported this. There was the jigsaw puzzle fit of the continents, there was fossil evidence, climatic evidence, etc. All of this kind of led him to believe that the continents were, in fact, drifting over the surface of the Earth, and that they're still drifting today.
The notion that Earth's continents, immensely massive and heavy slabs of granite, could somehow float around like enormous chunks of ice on water, did not sit well with the scientific establishment at the time.
So in fact, there were many people who denied that the jigsaw puzzle fit was evidence of continental drift. And one of my favorite counter-arguments was one famous American scientist, a man named Bailey Willis, who was professor of geology at Stanford, argued that the fact that the fit was so good proved that they couldn't possibly have been connected, because if they had been connected and broke apart, then during the process of breaking up, the continental edges would they'd get kind of bashed about or fractured, busted up, it'd be sort of a mess, and it couldn't possibly be so good.
Actually, I think the biggest trouble was that we didn't have a mechanism. We didn't understand how it could be. Because we say the continents were together and then they pulled apart, And it was just really hard to imagine how the continents could kind of plow through that solid rock.
They looked at his ideas and they said, well, your mechanisms don't work. And realistically, that doesn't work for, as an excuse, simply because of the fact that, well, their fixist ideas didn't work either. There was no mechanism for explaining how other things happen on the face of the earth. So, when Wegener came up with this idea, it was simply because they didn't want to believe him more than anything else.
It's not the case that there was no mechanism, because that's something that has often been said about continental drift, and you can find that in many textbooks, and it's just completely wrong. Because in fact, the exact same mechanism that we accept for plate tectonics today was put forward in the 1920s, and that's the idea that drift was driven by convection currents in the mantle.
The most negative reactions to Wegener's ideas were voiced in the U.S., where scientists had a very different view of some fundamental scientific principles that directly contradicted Wegener's theory. One such difference concerned isostasy, the principle of buoyancy which allows icebergs to float and continents to stand high above sea level and not collapse under their own weight. Wegener's radical new theory could not be valid if U.S. notions about how isostasy works were correct. For European scientists whose view of isostasy was quite different, there was no such conflict.
And therefore they were more able to consider the idea of continental drift without having to abandon some other important principles that they adhered to. So in a sense, what it really was that Americans had to give up more to accept continental drift than Europeans did.
But the disagreement between the U.S. and European scientists over Wegener's ideas went well beyond isostasy.
One of the reasons why Americans reacted more negatively to his ideas than Europeans did was an argument about scientific method. Essentially, Americans had a very strong view that good scientific method put facts first, that it should be empirical in the sense that you should go out into the world, learn about the world, observe in an as objective a manner as possible, and then only after you had really looked at a lot of things, then you could begin to develop a theory to explain it. A lot of Europeans didn't view it that way, and particularly Germans didn't view it that way. Germans had a view which is closer to what I think most American scientists believe today, that good science has to be informed by theory, that you have to have an idea that organizes your observations, that if you go out into the world and just collect facts, it's like collecting pebbles at a beach. It's sort of random and disorganized, and it won't get you anywhere. So German scientists tended to be much more theory-oriented, and they would often begin a book or begin an essay with a theoretical idea. So Wegener did what was normal for a German scientist in that period to do. Americans read it and said, this guy is prejudiced, this guy's dogmatic, this is bad science. He's not letting the evidence speak for itself. He's got an idea, and then he's using that idea to force the evidence into his argument. And so from the American point of view, his work seemed very dogmatic, and so he was extremely harshly criticized to the point that people said, this is bad science.
In 1930, Alfred Wegener went to Greenland to take measurements of continental motion, measurements which he hoped would finally confirm and legitimize his theory. But it was not to be. Wegener died of a heart attack during that expedition. His theory, however, did not die with him. In 1935, Japanese scientist Kyu Wadati speculated that earthquakes and volcanoes near Japan might be associated with continental drift. 5 years later, seismologist Hugo Benioff plotted the location of deep earthquakes at the edges of the Pacific. His charts revealed a circle of violent geologic activity known as the Pacific Ring of Fire, surrounding much of the Pacific. Benioff, Wadati, and others wondered what could cause such an orderly pattern of deep earthquakes. Was it possible that Wegener could have been right after all? That question would go unanswered for some years to come. In the meantime, however,